What is a wave? The best introduction into waves is to first delve into its graphical features. The first feature to highlight is the wave's direction of propagation. This is the overall large-scale direction the wave travels despite its back and forth motion on a smaller scale. So even though the individual points go up and down, the overall wave travels left to right. And that's also why we measure the x-axis, distance, in meters, the SI unit of distance. We measure wave propagation with distance, but we can also map it over snapshots in time. These are evenly spaced time intervals, and as you can see, the overall wave travels left to right, but any one point strictly goes up and down. Next is the amplitude, which is essentially the maximum displacement of the wave in the vertical direction. Thus, the y-axis measures vertical displacement of points along the horizontal length of the wave. When we hit these maximums, we form what are called peaks and troughs. From there, we define wavelength. As we can see, a wave is cyclical in nature. So we define the horizontal distance it takes to repeat itself as the wavelength, and we represent it by this little lambda symbol. Wavelength is also the peak-to-peak distance and the trough-to-trough distance. That wavelength is often so small that it is measured in nanometers. So when you're reporting your answer, you might have to describe it in nanometers, meters, or both. And as a reminder, there are 10 to the 9 nanometers in a meter, as well as 10 to the negative 9 meters in a nanometer. So these are useful for conversions relating to waves and wavelength. Also, wavelength isn't just the length between peak to peak and trough to trough. As I said, it's the length it takes for the wave to repeat itself because the wave is cyclical in nature. Lambda is generalized to be the horizontal distance between any two consecutive points along the wave with the same height and the same slope. As with the example in the previous slide, this is a wavelength because these are two consecutive points of the same height and the same slope. However, this is not a wavelength because even though these 2 points have the same height, they do not have the same slope. This slope is negative, this slope is positive. This is also not a wavelength because even though these 2 points have the same height and they have the same slope, they are not consecutive in sharing these features. These are actually categories of waves based on their range of wavelength. This is basically saying a radio wave has a really, really long wavelength about the size of a building, the length of a building, whereas we get something like gamma radiation, the wavelength is as large as the width of an atomic nuclei. Now, visible light falls right in the middle, and that's where we see the colors. Here's another way to depict wavelength as existing on a continuous gradient. And here you can really see what exactly the values are and the ranges that each of the different categories of wavelengths fall in. For example, radio waves are pretty much anywhere between like 10 to the negative 1 meters and anything greater than that.